Hello, welcome to today's math class. Today being a great day, we have this math question before us. The question is, bracket open, the 8th root of 3. The 8th root of 3 to the power of minus 1 equal to bracket open another 8th root of 9 close bracket all raised to minus 1. What is the value of A? That will satisfy this equation. All right, so let's take a solution from here. Take a solution. Now look at this. This is a radical. So we want to rewrite this expression we have here. So this could be written as our 3 to the power of 1 all over A all raised to the power of minus 1 plus same thing we're going to do here, which is 9 to the power of 1 all over A, then all raised to minus 1. This is equal to 30. Okay. Here we are having 3 as the base number here. Here we have 9. We can express 9 as 3 to the power of 2. So let's rewrite this here. So we have here 3 to the power of 1 all over A, all raised to the power of minus 1, plus bracket our 3 to the power of 2 all raised to our 1 all over A. And let's put this in a square bracket. All raised to minus 1. This is equal to our 30. Good. Now, because from the first expression we have here, we are having 3 to the power of 1 all over A. We want to achieve same. In other words, we want to bring 3 to the power of 1 all over A here too. So we're going to apply a law in indices which says that if you have your K, or let's take our P to the power of, let's say, to the power of your M, N, this is same thing as our P to the power of M bracket N, which is equivalent to our P to the power of N bracket M. So we can interchange the position of the components at the top, at the exponent. Okay, so if we can do that, then we can move this out here and bring this in. In other words, we can push this in, bring this out. Okay, so let's first of all push this in and bring it out. So this is going to give us here, this now implies our bracket, our 3 to the power of 1 all over A, close bracket to the power of minus 1, plus our square bracket into our bracket 3 to the power of 1 all over A, close bracket, all to the power of 2, or into our square bracket minus 1 equal to 30. Good. Again, applying this law again, then we can move this out here. So this is going to give us here a bracket 3 to the power of 1 all over A, close bracket minus 1, then plus bracket our 3 to the power of 1 all over A, close bracket minus 2. This is equal to 30. Easy. Now let's figure out something here. What we have in this bracket, same thing we have in here. So here we can do a simple substitution here, right? Good. So let's make a substitution. So from here, let's say here, let's take our t. Let t be equal to our 3 to the power of 1 all over A. Okay, so let's continue here. All right. Now from here, what we do, wherever we see 3 to the power of 1 all over A, we put in t there. So the first one is going to give us here, implies that our t to the power of minus 1 plus our t to the power of minus 2, this is equal to 30. We can rewrite this by removing this minus attached to the exponents, right? According to the law of indices again. So this is same thing as 1 all over t to the power of 1 plus 1 all over t to the power of 2 equal to our 30. We want to do away with this alphabet or this variable at the denominator. And the highest power here is 2. So we multiply through by t to the power of 2. And so this is going to give us 1 all over t times t to the power of 2. First place there, here we have 1 all over t to the power of t, 2 times t to the power of 2, close bracket, equal to our 30 times t to the power of 2. Because whatever you do to the right hand side, you must do to the left hand side according to the law of equation. And so t will cancel out t here, will give us 1. T will cancel out one of the t here, we have here 1t left. The t squared will cancel out t squared. And so we end up having t plus our 1 equal to 30t to the power of 2. Just rearrange. Move this to the side of the equation and rearrange. So this is going to give us 30t to the power of 2 minus t minus 1 equal to 0. Wow. So what kind of equation is it? This is a quadratic equation. And how do we solve this kind of a quadratic equation? Yeah, we check if we can use the factorization method. So from here, look at the constant we have here. The constant we have here is minus 1. But look at the coefficient of t to the power of 2 is 30. So what we do, we use this 30 to multiply this minus 1, and that will give us 30. And so we look for the factors of 30, 2 of them that when we multiply together to give us minus 30, they added together to give us minus 1 here. And definitely that will give us 6 and 5. But what will be the sign? That will give us minus 6 plus 5. All right, so we can rewrite this expression here to give us here 30 to the power of 2, 30t to the power of 2, then minus our 6t plus our 5t minus our 1 equal to 0. So what we do here, we can now put this and this in bracket, put this and this in bracket. What is common here is 6t. So we have here 6t bracket. 6 into 30 will give us 5. We are left with 1t and minus 6t into 60, we are left with just 1 plus bracket. Then we have here plus, what is common here is just 1. So we have here 1 bracket 5t minus 1, everything equal to 30. So let's take a look at the terms we have inside the bracket. They are the same. So we take one of the terms inside the bracket, then we take this that is outside and this that is outside. So if we do that, it's going to give us our 5t minus 1, here bracket 6t, the plus 1, everything equal to 0. Sorry. Then if we apply the zero product rule, we equate this to 0, we equate this to 0. So that means our 5t minus 1 is equal to 0, or our 6t plus 1 equal to 0. And so this will give us 5t is equal to positive 1, or our 6t is equal to minus 1. Right? Good. So automatically, we divide this by 5. We divide this side by 5 also. We divide this by 6. We divide this by 6 also. This leave the system. This leave the system. So let's continue here and see what this gives us. So from here we are left with t. Here we also left with t. So we're going to have this to be our t. We have t1. So let's give this t1 is equal to 1 all over 5 r. Then we have our t2. T2 is equal to minus 1 all over 6. Easy. But again, from the beginning, we do not have t. What we have here is a, and that is what we are asked to look for. So we recall where we said, let our t be equal to 3 to the power of 1 all over a. So from here, we're going to have here, say, recall that we said 3 to the power of 1 all over a is equal to t. So we take our case 1. Look at our t here. So we have our t, we have t1 is equal to 1 all over 5. So this now implies that our 3 to the power of 1 all over a is equal to 1 all over 5. Oh, We take log to both sides of the equation. So from here, let's take log to base, I would take log to base 10. Yeah, let's just take log to base 10. I could as well use log to base 3. So let's go straight to log to base 3. So this is going to give us here log our 3 to the power of 1 all over a, then base 3. This is equal to our log 1 all over 5, and base 3. Okay. So according to the law of logarithm, the power law of logarithm, we move this to this side of the equation. What do you mean by that law? We say that if you have log p to the power of k, so move this to this side, so this going to give us k times log p. Okay? Alright, so with this, we are moving this to this side to give us 1 all over a times log 3, this 3 is equal to, yeah, this is division. We can equally apply the division law of logarithm here. And the division law of logarithm says that if you have, put it here, says that if you have your log m all over n, this is equal to your log m minus your log n. All right? So this is 1. So this is going to give us here log your 1 is 3 there minus log your 5 is 3. Easy. Now log 1 base any number to give us what? To give us 0. Yeah. So from here, it's going to give us, and here again, log 3 base 3 will give us 1. So the whole of this will give us 1. So we're going to have 1 all over a is equal to minus log 5 base 3. Easy. Again, we are looking for a. So we find the reciprocal of everything here. So if we find the reciprocal of everything, this is going to give us a is equals to 1 all over with our minus sign here. Then we have log 5 is 3. This is the value of our a that will satisfy the original equation. Very easy. Okay. Now let's look at case 2. From our case 2, we are having t2 is equals to minus 1 all over 6. But here we have that our our a must be greater than, from this expression here, our a must be greater than 0. And so there's no solution here. For this, no solution. No solution. All right? So there's no solution here. So the answer that satisfies this equation here, which is what we have here, is a equal to minus 1 all over log 5 base 3. Again, we can as well change this to base 10. Okay? We can change this to base 10. And if we change this to base 10, this is going to end up giving us minus log 3 all over log 5. That's another way of expressing this answer, changing it to base 10. Okay? So this is same thing as our minus log 3 base 10 all over log 5 base 10. This answer here and this answer, they are the same. Now, we can verify if the answer we got for our equation actually satisfies the original equation. So let's do a little verification to check if the answer actually satisfies the original equation. So let's take a look at our question here. And here we said we can rewrite this expression here, right? So let's rewrite this. So we know that this is same thing as 3 to the power of 1 all over a close bracket up to minus 1 then plus bracket. This we did the other time as our 3 to the power of 1 all over a, right? The close bracket all to the power of 2 then into our square bracket, then minus 1 equal to 30. In other words, it is only this side we want to deal with, right? So we can move this outside here to give us here our bracket 3 to the power of 1 all over a, then also minus 1 plus bracket our 3 to the power of 1 all over a, then close bracket minus 2 equal to 30. Now look at what I want to do here now. From here, we are having 1 all over a already, and we are having 1 all over a here. It was from here, we simplified that to get the actual value of our a. In other words, if we put the whole of this into this place here, we're still going to come up with the same result. But a quick one, let's take this now, which is 1 all over a now, because this expression we have here now, if you simplify it down, it's going to give us this, right? Good. So let's put in what we have in here there. So it's going to give us here our 3 to the power of our minus, we have minus log 5 base 3, they're all to the power of minus 1, there plus our 3 to the power of minus log 5 base 3, right? All to the power of minus 2 equal to 30. Easy. We can bring this minus to this side. And we can only bring this minus to this side because here we have invisible 1, here we have invisible 1. So rewriting this is going to give us minus, a bracket of 3 into our log 5 to the power of minus 1. According to the law of logarithm, the base 3, the close bracket to minus 1 plus, we do same here, we have bracket open 3 into our log 5 to the power of minus 1, base 3, close bracket, or into minus 2 equal to 30. Just watch out for the manipulation. All right. Now here we're having 3 to the power of log 5 minus 1 base 3. So this 3 will go with this log base 3. This 3 will go with this log base 3. Yeah. So we are left with what? 5 to the power of minus 1 minus, or in bracket minus 1. So this is going to give us here 5 to the power of minus 1 bracket minus 1 plus, here we're going to have 5 all to the power of minus 1 in bracket minus 2 equal to 30. Easy. So according to the law of indices, okay, it says that, I thought I wrote it somewhere, okay, law of indices, which says that if you have your a to the power of m, n, this is equal to a to the power of m in bracket n. So if we look at this law, we can use this to times this. So we have this to be our minus 1 times minus 1 will give us plus 1. Okay, so automatically this is going to give us 5 to the power of 1. And 5 to the power of 1 will give us what? 5. So here we're going to have this to be 5 plus. So here we have minus 1 times minus 2 will give us plus 2. So this is going to give us 5 to the power of 2. And 5 to the power of 2 will give us what? 25, which is equals to 30. Then 5 plus 25 will give us what? 30, which is equals to 30. So this shows that the answer, yeah, satisfies the original equation. All right, so this brings us to the end of this math class. I know checking for the authenticity or the correctness of the roots. So I found, I know you may have some questions there. Then drop your question there, or you have any criticism, drop it in the comment section. But again, let's be kind of friendly in our comments. Some persons are so blunt in their comments. Okay, you know, it's not easy to create content if you don't know. Creating content is one of the most tasky jobs so far. Okay, it's not easy. And so when you want to criticize, do a constructive criticism. Okay, we are not shy away from our mistakes or not taking corrections. No, we are there to take corrections, and it is your criticism that actually makes us to study harder or make more research. But your criticism should be constructive, please. Okay, thank you for being there for Online Maths TV. And until we come your way again, keep winning. Remember, Online Maths TV loves you dearly, most especially Jakes loves you. Bye for the now.